Hey guys, Mr. Roden here. I'm here to go over your properties of triangles test, and this will give you an opportunity to make your corrections, get that half credit back to me as soon as possible, and I'll get it into the computer. So we'll see how you did. I'm going to pull up the key, and I'll just going to explain it. I already have the key made up, so I'm just going to go through and explain some key points here. So let's take a look. Here we go. All right, so let's look at number one. Hopefully you can read this with my chicken scratch here. Make it a little bigger. Here, let's do this. Get this go down a little bit. Sorry, I should have had this all set up before that. All right, so here we go. Most of you did really well figuring out the parallel sides. I think everyone got this one correct, so I'm not going to spend a ton of time on it. But what I'm noticing is my pen on here. So remember, okay, so the parallel segments, so I'm not going to do all of them. So why is AC and FD? Well, obviously, AC is right here. So FD, since it's the mid segment, would be parallel. So those would be parallel. Likewise, we just go through, and most of you did a really nice job on that, so I don't think I need to talk too much about it. So that's how I got the first one, and the other ones just kind of follow that same mid-segment opposite side rule. This one, most of you did well on. You just had to remember that the mid-segment is always half the size of the opposite side, so I just multiplied the mid-segment times 2 right here. So this was our mid segment here in green. Right here, this 3x is our mid-segment. If you multiply it times 2, it always equals your opposite side. So this is your opposite side. And then doing a little bit of algebra, 2 times 3x is 6x. What I do? I subtracted 5x from both sides, and I got x equals 4. And that was just worth 1 point. So is number 1, which is worth 1 point, guys. Okay. All right. On this one right here, it says EB, and those are midpoints right there, and that's 13.6. So remember, it's just simple math here. If you take 13.6 and multiply it by 2, you get 27.2, and that is the length of DC, which is the longest side. Again, 1 pointer, no big deal there. Most of you did well. Okay, so here's where things started getting a little shaky for some of you. Now, some of you tried to use the actual mid-segment theorem, but it's not saying to use the mid-segment theorem. It wants you to actually show it. So first of all, most of you did really nice on the graph. So congratulations, you guys are good at graphing points and drawing shapes and nice and all that. So I gave you a point for that. Okay, so I gave you a point if you just drew, and you had to use, and actually you had to do a little bit of geometry because you had to use the midpoint formula to find U and W. Okay, now, how do you get the other 2 points? The other 2 points, the next thing you need to do is you need to find the slope, okay? Well, the slope of UW is 5, okay? You went rise 5, run 1. From W to U, you rise 5 and run 1. And the slope of YZ, or ZY, is rise 10, run 2, which also is 5. So what have you just shown? You've just shown using the slope formula that these 2 sides are parallel to each other. And that's what that question was asking for. Some of you didn't show me the slopes. So you had to show me the slopes to get 1 point. And the last thing we needed to do is show that ZY is 2 times the length of UW, or UW times 2 equals ZY. And that is a good distance formula problem. So if I use the distance formula on UW, I get the square root of 26. If I do the square root, if I get to do the square root distance formula on W's, excuse me, this is UW was 26, and ZY, sorry, this should be ZY, my bad, sorry guys, ZY was a square root of 104. Now, you could do 2 things. You could put those in your calculator and see that square root of 26 is half the square root of 104. Or what I did is I just went through and reduced radical formed it, And I'm noticing that the square root of 104 is really equal to square roots of 26. So that's pretty cool, right? So one of them is the square root of 26. And when you reduce radical form, it's 2 square roots of 26. So you can see that this one is 2 times this one. Okay? All right, so what do we got here? We've got the midpoint formula for a point and the graph. We got the slope for a point, and we've got the distance formulas showing me that it's 2 times the distance formula for a point. And that's how you get the 3 points on number 4. Okay, so let's take a look at number 5. Now, number 5, I drew it out. Okay, so I just went through and I drew it out. It's not to scale or anything. And it wants to know what is the longest mid segment. Okay, which the longest? Well, what you have to do is you have to look at the angles and you have to say, well, FD right here is the longest mid segment because it lies opposite the 80. The other two lie opposite the 40 and the 60, so those wouldn't be as long. So FD would be our answer right there. So a good thing to do is just draw it out and see it. Does that sound good? Okay, awesome. All right, now the next one, and that was just worth 1 point, guys. The next one, we're putting them in order from least to greatest. Least to greatest. It didn't ask for an inequality. If you did do an inequality, I shouldn't have marked you down for that. So remember, the greatest angle lies opposite the greatest side, and vice versa. The smallest angle lies opposite the smallest side. So angle E comes first because it lies opposite of 3.2. 3.2 is the smallest one of these numbers. Let me make this a little bigger, guys. Sorry. I know I should have had this all worked out already, but all right, so that's bigger. All right, and likewise, so then it goes F and D. E is the smallest because it lies opposite the 3.2. F is the middle one because it lies opposite the 3.4, and D is the greatest because it lies opposite the 3.7. Okay? Likewise, the greatest side lies opposite the greatest angle. So now we're talking sides. So which angle is the greatest? It's angle C. What side lies? We want least to greatest. So what's the least side? What's the smallest angle? Angle B. So what lies opposite angle B? AC. So there's the smallest one. And then you go, okay, what's the next one? Well, that's 65. That's angle A. What lies opposite angle A? BC. There it is. And then what lies opposite the biggest one is lies opposite the 70, which is BA. Piece of cake. All right, so that's how we would do this one. Most of you did a pretty good job on this one, but here's the thing, guys. Remember, this problem right here, X can change. X can be the smallest side, or X can be the largest side. So just because it's longer than the other two now doesn't mean that this X can shrink and grow. That's when you ever have a variable on a shape, it means the shape can change, okay? It doesn't stay the same. So it's not always going to look like this. This is just one kind of possible triangle with these kinds of lengths. So X can shrink or grow, but it can only shrink or grow so much because the triangle inequality rule says when you add the two shortest sides, it has to be greater than the longest side to make a triangle. That's the triangle inequality theorem. So how would we do that? Well, the first thing is, let's say that X is the longest side. So 8 minus 3 is 5. So it cannot be any shorter than 5, okay? Let's say X is the shorter side. Well, 8 plus 3 is 11. So X has to be less than 11. So if X is the shortest side, it has to be 5 or greater, or it has to be greater than 5. If X is the longest side, it has to be less than 11. And this is the kind of the range in which, or the inequality in which your X's can be. Okay, some of you put 8 right here. It can't be 8. It can be bigger than 8. It just can't be bigger than 11. So that was the main mistake, is some people put 8. A lot of you had the 5, but some of you put 8. It should be 11 because you got to add the 8 and the 3 to get 11. Okay, awesome. All right, number 9, determine whether a triangle can be formed with a given length. Well, what you need to do is you need to use that concept that we just talked about called the triangle inequality theorem. The triangle inequality theorem says when you add the two shorter sides, it has to be longer than the third side. In this case, they give us 3 actual sides. So 29 plus 59 is 88. 88 is not greater than 89. 88 is not greater than 89, so the answer is no. It can't be. Some of you are talking about 180 degrees in a triangle. Guys, it has nothing to do with the degrees. It's side length, okay? Some of y'all were doing degrees, and I didn't know where that came from. So remember, the two shorter sides, when added together, have to be longer, strictly longer than the longest side. That's the triangle inequality theorem. All right. So next one is show that PQ is less than RS. Okay, so this was a 2-pointer, guys. The other twos were just 1-pointer so far. All right, so this is our 2-pointer here. Why is this a 2-pointer? Well, the first thing I gave you is I just gave you a point for getting 80 degrees right here. So that's +1. You got to do that. So you don't know, you can't really figure out the order of things until you have all the angles. In this case, you had to do a little triangle angle sum theorem to figure out that 80. So I gave you a point for that. So that's one of the points. And then what you had to do is in triangle 1, you have to just put the sides in order. So with PQ is the smallest in triangle 1. This is my triangle 1 on the left. RP is this next one, and then QR is the biggest, greatest one because it lies opposite the 100. And then we have, in the second, we have RS, we have RP, and then we have PS. Okay? Well, look here. PQ is less than RP here, but RP is less than PS here. So PQ has to be less than PS, because in this one it's let's see here, let's just make sure PQ here is less than RP, but RP is less than PS, so that means that PQ has to be less than PS. Kind of see that? Hopefully that made sense. And that gives you another point. So there's the 2-pointer. You get one easy point for the 80 degrees, and you get another point for just having these two inequalities and blah, 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 explaining what you did there. Okay, so that's worth 2 points. All right, let's move on to the next one. I need to move this down a little bit, make it biggie it here a little bit. All right, let's do that. Let me move it. Sorry, guys, I should have this all arranged earlier. Move this down. Let me biggie this up a little bit. All right, so what do we got here? On number 11 is the exterior angle theorem. Most of you did a nice job. Remember, the exterior angle is always equal to the sum of the remote interior angles. 46 and x are the remote interior angles. So x plus 46 equals 134. And then I think you just simply subtract 46 from both sides here. And my key 46, sorry, and then that gives you x equals 88 for 1 point. All right, the next one was a 2-pointer. So the first thing, before you can do this problem right here, ladies and gentlemen, you just have to find x. To figure out this number 12, you have to find x. So I went through and I just said that, okay, so remember the two remote interiors always equal the exterior. So 6x minus 1 plus 5x plus 17 equals 126. And then I combine like terms. So 6x plus 5x is 11x. Negative 1 plus 17 is 16 equals 26. So 11x equals 110. So I get x equals 10. When you take 11 divided by, what do we get? 10 here, right? And then we just do, then we plug it in for h, so that's 1 point. And then the easiest thing in the world is you just go over to angle h, you plug in a 10, so 6 times 10 minus 1 is 59 degrees for a point. Okay. All right, determine the measure of the indicated exterior angle. So we want to find this exterior angle. Now, before we can do that, we have to figure out x first, okay? Because we can't figure out anything before we know x. So remember, the triangle angle sum theorem says there's always 180 degrees in a triangle. So 2x plus 3x plus 3x plus 4 has to equal 180 because there's 180 degrees in a triangle. Doing the algebra, well, we got 3x plus 2x plus 3x gives us, let's see here, 8x. Plus 4 equals 180. We subtract 4 from both sides and get 176, is that right? And then we divide both sides by 8 and we get 22. So that's 1 point for getting x there. So you had to show me that you got x equals 22 for a point. And then you just have to, so if x equals 22, then you just say, okay, well, 2 times 22, you just do the math, right? So 2 times 22 and 3 times 22. So let's see here. You just add those two. So 22 times 2 is equal to 44, right? So this is 44. And then 3 times 22, so 22 times 3 is, what, 66, right? And I believe that 66 plus 44 equals 110 for a point. All right? Okay, so the next one, this is how I did it. It said the exterior angle drawn measures 150 degrees. And the measure of angle D is twice the measure of angle E. Find the measure of the two remote interior angles. Now, most of you did a really nice job on this and didn't do it like I did, but that's fine. I gave you credit as long as you got the point. This is just worth 1 point. All right. So what I said is, okay, I know if this angle is x, then this has to be 2x because it's twice. So I said 2x plus x equals 150. 2x plus x is 3x. Dividing both sides by 3 gives me, what, I think I got 30 there, right? And then doing the math, actually, 2x, this is not 30. This should be 50, my bad. Okay. So that's 50. So we know that measure of angle E equals 50. And the measure of angle D is twice that, which is 100. So, and some of you got it different ways, and I'm fine with that. That was worth a point. Gosh, I think number 15 was probably the easiest one. It had a little word problem, but it's just an exterior angle. So remember, guys, the exterior angle always equals the sum of the two remote interiors. Well, what are the remote interiors with this? Well, 20 plus 90. So all you had to do is add those up and get 110 for a point. Nothing too scary there, right, guys? All right, I think we're on the last page here. Okay, let me move this down a little bit. Move this over. All right, so number 16. Okay, so this one is going to use the isosceles triangle theorem, okay, or variations of that. So we know, since this is an isosceles triangle, it's an equilateral triangle, but it's isosceles, so we have two base angles here. So we can say that 5x minus 12 equals 3x minus 4. Doing the math, we get x equals 4 for a point, because it just wanted x. All right, on this one, we wanted to know BC. So remember, this is the angle bisector theorem. And remember, we're given, it's a angle bisector, and these two are the shortest distances. These right angles are very important. If they didn't give us these right angles, we couldn't write this equation. So we can set these two equations equal to each other using the angle bisector theorem. And 6y minus 16 equals 4y plus 6. What did I do here? Oh, I subtracted 4y from both sides. 6y minus 4y is 2y, minus 16 equals 6. And then I added 16 to both sides, and I got 2y equals 22. And I divided by 2 and got 22 divided by 2 is 11. Now, that's worth a point. The other point, you just have to go, we want to know what the measure of BC is. So BC is right here. So we simply just put 11 into 6y minus 16. 6 times 11 is 66, minus 16 is 50 for another point. So pretty easy points, they're just algebra points, right? Knowing that. All right, this is the converse of the angle bisector theorem, which says these two angles have to be equal to each other because the two distances are equal to each other. So again, we're just setting the equations equal. 6y plus 3 equals 7y minus 6y plus 3 equals 7y minus 3. So doing the math here, so what did I do here? Over here, I'm doing the math. So what did I do? I subtracted 6y from both sides and got y. And then I added 3 to both sides and get y equals 6 right here, okay? And then I just put 6 into this equation for, what are we trying to find? GDF. GDF. So we're trying to find this angle right here. You could put it in either one because it's going to be the same, but 6 times 6 plus 3 gives me 39. All right, so here's the next one. Now, some of you used the perpendicular bisector theorem on this, but again, we're proving the perpendicular bisector theorem. Can't use it in the proof. So here's the deal. So you prove that AB, angle A is congruent to angle C, given the midpoint is M is the midpoint of BC. Notice, guys, excuse me, it never told us that this is a right angle. It never said that those are right angles. Are they right angles? Yes. But you can't deduce that from right off the bat because you don't want that. Then yes, you could use the perpendicular bisector theorem. But we're not proving, what we're doing is proving you want to use the perpendicular bisector theorem. We want to use congruent triangles. All right, so the first thing we did is I just said AB is equal to AC. And that is just a given because it's marked right here in the picture. That's marked in the picture. So that was marked in the picture. That's a given. I gave you a point for that. M is the midpoint of BC. So that's given. Now, here's where not all of you, you have to clearly say that BM equals CM by the definition of the midpoint. I want that. It's not an obvious one. I want you to understand what it means to be a midpoint, okay? So I gave you that for a point. And then we can say that AM is congruent to AM. That's the reflexive property. Most of you do a really good job on that. And then we can say the two triangles are congruent because of side, side, side. So that was what I was looking for. Side, side, side is what I was looking for. Okay, and then we can state that since the two triangles are congruent, then we could say those two base angles B and C are congruent because of CPCTC. So let's see, 1, 2, 3, 4, 5, 6 points on that proof right there. So pretty beefy little proof there, but that's some of you missed points. That was the one where that got some points, but it was out of 6, so make sure I graded that right. All right, the last one, most of you did a really nice job on. So the first thing we do is we need to use the midpoint formula to find the midpoints. To find medians, you need midpoints. So I found these 3 midpoints, which was, what do we got? If I could read my writing here. So it looks like U was the point 1, 3, right? 1, 3. And it looks like V was the point 5 over 2, 2, which is what? 5, that's 2.5, 2. So that's right here. Did that one. And then the last one is negative 1/2. So negative 1/2, 1. And that's, I called it N right there. And then I just connected my medians, and I got a point of concurrency right here. And it looks like the point of concurrency was at 1, 2. And that was worth 2 points. You get a point for finding the centroid, and then just a point for doing all this midpoint work and graphing. Okay, that should be a 33-point quiz right there, guys. Go ahead and make those corrections. Get them to me as soon as possible. If you have any questions, if you want to speak to the real Mr. Roden, not video Roden, you can do that also. You guys have a wonderful day. See you later.